So next one is the numerical on the Z parameter. Okay, so find the Z parameter for the circuit and shown this. Okay, guys, please do it in your own copy and then I will do it. So coming to the solution. So the circuit is looking like a T network because in this network no elements are there. Only these three branch there is a elements is there. So this is looks like a T network. Okay, so we know that is V1 from this matrix. Matrix is, just remember this matrix. This is Z. Okay, so V1 is the Z11 I1 plus Z12 into the I2. Okay, and V2 is the Z21 into I1 plus Z22 into the I2. Okay, this is the Z parameter equation. Just remember. And now when port B dash is open circuited, then Z11 is V1 by I1 and I2 is 0. We say this is the equation 1. Okay, the first equation. Or we can say it could be, if I form this in another form, that is V1 equal to Z11 into I1. This is our first equation. Okay, and you from this picture you can see, if this part is not there, this part is totally absolute because this is a 0. And this is there. So V1 is I1 and I1 coming in this loop. Okay, so I1 ZA and I2 ZB. Sorry, I1 ZA and I1 ZB. So we can, another way we can write down that V1 equal to I1 into ZA plus ZB. This is also equation 2. So if we equate, if we equate equation 1 and equation 2, then I1 ZA plus I1 ZB is equal to Z11 into I1. So from this equation 1 is this and equation 2 is this. So if we equate this, because these are the V1 and the V1. So this V1 and V1 is equal. This V1 and V1 is equal. So we can cut off this I1 and I2. So ultimately we get ZA plus ZB equal to Z11. Okay, this is the first element. Second, we go for Z21. So this is Z21. So this is, we know, V2 by I1. Okay, when I2 is 0. So when I2 is 0, Z21 is the V2 by I1. So we can write that the V2 is I1 into this Z21. So this is the another equation, that is 3. And we also know V2, because V2 is open. So what happens if there is the circuit, if we measure this point is open but this point is connected, okay, so current is flowing in this way. So if I measure them through this multimeter, the voltmeter, we can find only V2 is applicable for this impedance, and current is at this I1. Okay, so this is the V2. So V2 is I1 into this ZB. This is a ZB. This is also the equation 4. So if we equating equation 3 and 4, then what we get, that is I1Z21, I1Z21 ZB. So this I1 cut out. So Z21 equal to ZB. Okay. So guys, next point is Z22, and we know this Z22 is when we open the input port, means I1 is equal to 0, then we get the Z22. So Z22 is V2 by I2. So every element has its particular name. Just remember this one by one. Just recall it. Just the previous class we have mentioned this. Okay. So so now so it is equation 5. So we can write that V2 equal to Z22 I2. Okay, and another equation, if you go for this circuit, you can find out this. This is GDA, this is GDP, I1, that is I2, that is V1, that is V2. So when I1 is 0, so this terminal is open, only this current is flowing, only this current is flowing. Current is flowing, that is I2. Okay. So you can see, so if this terminal is open and if you measure this voltmeter voltage, then only this I2 current is flowing and it is going to the ZB. So we can write V2 is ZB into I2. This is the equation 6. So if we equating equation 5 and 6, we get Z22 I2 equal to ZB I2. Now we can cut out, so Z22 is the ZB. Just remember this thing, we have to mention it. Similarly, okay, and we can write that is V1 is Z12 and I2, and that is the equation 7. Another way, we just remember the circuit. Okay, so here this I1 is open. So I1 is open and this current is flowing, that is I2. And we know if we want to measure the V1, look, voltage can be measured whenever there is open, but current only measured whenever the circuit is closed. So voltage whenever it is measured, here and here is the same because there is no current flow is there, so no potential drop is there. So this terminal is the V1 terminal. So it is only I2 into ZB. So V1 here from this equation, if we measure voltage across this, V1 is the I2 into ZB. That is the equation 8. So from this case, so if we so if we nullify these things, I2 and I2. So ZB equal to Z12. Look, here we also get the ZB is Z12, and in the previous cases also we get ZB whenever this V2 was open, then ZB is the Z21 also. So if we give the proper name, if we give the proper name, that is, just recall this thing because so many times this type of questions are coming. That is, what is Z11, Z, sorry, Z21, Z12, and Z22. Everything has the exact name. Just remember, Z11 is called open circuit input impedance. Open circuit input impedance. Okay. Then Z21, that is called open circuit forward transfer impedance. That is called open circuit that is Z1 and 2, that is called open okay. So that is Z22. Okay. So that is coming Z11. What is the Z11? That is coming ZA plus ZB. What is Z21? Z21 is ZB. What is Z12? Z12 is also ZB. And Z22 is what is ZC plus ZB. ZC plus ZB. So just remember the Z22. Maybe I skip these things. Z22 is V2 by I2. Okay, when I1 is 0. So V2 is I2 into V2 is I2 into Z22, and another way V2 is also I2. V2 is also I2 plus ZC plus ZB. So from this case, we can find out this V2 and V2 is equal. So this I2 Z22 is equal to I2 ZC plus ZB. So if we cut this I2, if we cut this, then Z22 is ZC plus ZB. So ZC plus ZB. So from this observation, we can find that Z21 and Z12 is the same because both are the ZB. same things is there. So now we can observe that Z12 and Z21 is the same. So the network is the bilateral network which satisfies the principle of reciprocity. So this is the satisfying the reciprocity theorem, and this is the bilateral network. So this is the all parameters. This is the Z parameters of this circuit which was given, and the value is of this, and this is the as this is the same. So this is a bilateral, and it is satisfied. It is lateral, and this is the reciprocity. Reciprocity principle. So this is the Z parameter. So if you have any question, you may ask me. Okay, I am going to stop.